Welcome back 3DSSPP users. I'm Kelly with the University of Michigan Center for Ergonomics, and I'm continuing to share with you some information and insights about the 3DSSPP software developed at the University of Michigan. In this video, I'm going to be talking about balance in the 3DSSPP. We've talked about balance a little bit up to this point, but to clarify, when we talk about balance in the 3DSSPP, we're talking about, will this person fall over? The 3DSSPP calculates whether or not the worker in question will fall over via a center of pressure calculation. This is a mathematical equation that determines whether or not the center of pressure is within a stability region defined by the location of the feet. So the support for the body is defined by the feet when standing, and postural stability occurs when the center of pressure falls within the basis of support. The 3DSSPP calculates the center of pressure at the level of the feet, and determines whether this location is within a stability region defined by the feet. Now that we've broadly defined what balance in the 3DSSPP is, I can tell you in a little more detail some specific areas of balance that the program takes into account when determining if a posture is viable. The center of pressure is actually the center of gravity plus the offset created by external loads on the body. The basis of support is essentially the outline of the feet that you can see here. The red dot is the calculated estimate of the center of pressure. A person's feet can support a posture if the center of pressure is within the basis of support. If it is not within this area, the person will fall over towards the center of pressure. Additionally, there is the functional stability region. This is an inner region that is smaller than the basis of support. Studies have shown that people tend to keep their center of pressure within this zone probably as a safety factor. In 3DSSPP, it is the green area within the basis of support area. It is within this area that it is best to keep the center of pressure. You might call it a safety zone. Those are two of the main areas that you'll want to keep yourself aware of at a high level when it comes to balance. But let's dive a little deeper by accessing the Standing Balance Report. To get to this report, I'm going to navigate to the Reports drop-down menu and select Balance from the options. The Standing Balance Report will appear, and you can see that there is a lot of information associated with this report. Here you can see that there's quite a bit more that goes into calculating balance than what we've covered up to this point. There's a lot of information, for one, and also there are additional dots aside from the red one we've already been acquainted with. To reiterate, the red dot is the center of pressure which covers all external loads and body segment masses. And again, balance in 3DSSPP is achieved by keeping this red dot within the basis of support defined by our avatar's feet. The yellow dot that you can see here is the body center of mass. This dot is not going to include things like hand and other external forces. The purple dots are the center of pressure for each foot. Moving away from this menu, we'll talk about three different balance scenarios that you'll likely run into while using the 3DSSPP. Acceptable balance, critical balance, and unacceptable balance. Acceptable balance is any scenario that has the center of pressure location within the functional stability region. With an acceptable balance, your worker's posture will be stable. Critical balance is any posture where the center of pressure location is outside the functional stability region and still within the basis of support. Here your worker will be on the edge of falling and may be uncomfortable. Finally, we have unacceptable balance, where the center of pressure is outside of the basis of support. This is a posture that cannot be maintained and the person in question will likely fall over. It's important to note that occasionally you will get an unacceptable balance posture if there is an external factor that the 3DSSPP does not know about. Take this bent over and reaching posture for example. The 3DSSPP sees this as an unacceptable balance posture, but the person would not fall over in the real-world scenario because they're supported by whatever it is that they're leaning on. So the 3DSSPP may not give us acceptable results for balance in these scenarios, but you can still use the results from various other sections of the program in these cases like low back compression, strength percent capable, and others. That's all for this tutorial on balance in the 3DSSPP. Check out further videos in this 3DSSPP tutorial series to learn more about how the software can help you analyze physical demands in the workplace. Thanks for watching.